let's solve this system of equation of three variables. This is example 2 on page 286. So when you see solve this system, it has three variables x, y, z. That means you're looking for what is x, what is y, what is z. Okay, you're looking for the answer for the x, y, and z. Let me rewrite this. Looking for what is x, first coordinates, what is y. I want to write this here. What is y? And what is z? Okay, you're looking for the value for x, substitute here, same thing here for y, same thing here for z. Looking for a constant value. Alright, similarly, let's call this equation 1, equation 2, equation 3. You do that so you can keep track of the procedure you've been doing, so you'll mess up with any equation. It's got to have a system, a systematic way to solve this system. So first, determine which variable you want to eliminate. You want to eliminate one variable so that you can convert these three equations to two equations with two variables. Look like you can eliminate, let's see, y, right? You look for x, y, and z, look like y. These two equations right here, you can eliminate the y right away because it has same coefficient with opposite side. So I'm going to take the second equation. And the third equation is 2x plus y plus 2z equal to 5. This is equation 3. Minus 2x plus y plus z equal to 5. 2x plus y plus 2z equal to 5. And I'm going to add them. Okay, the goal is to eliminate the y. So it's negative 8x plus 2x is negative 6x. Negative y plus y is 0. Plus z plus 2z is 3z. Negative 5 plus 5 is 0. Simplify, we get negative 6x plus 3z equal to 0. Now, you can stop here, or you can simplify further. Look at this. 6 and 3 and 0. 0 times anything is 0, okay? It look like you can simplify by 3 on both sides, okay? So let's simplify on both sides. Let's divide 3, 3, and 3 on both sides, just to make the coefficient smaller. 6 divided by 3 is 2. Don't forget the side. 3 divided by 3 is 1z. 0 divided by 3 is 0. So you just change this equation, negative 6x plus 3z equals 0, to this equation would look similar, right? These two equations are equivalent. So you can use this or use this. It's up to you. But using this equation is easier because the coefficient is smaller. You're dealing with 2 instead of 6. I mean, you're dealing with negative 2 instead of negative 6. Okay, you're dealing with 1, the coefficient 1 instead of 3. So let's call this equation 4. So I have xz here. So I need one more equation with the same variable xz so that I can solve for xz. Alright, so far I use these two equations, okay? I'm using the second equation and the third equations, alright? So I need to find another system. So let's see. My goal is to eliminate the y, okay? So let's see. I can use, actually it's better that you're using the first and the third. The reason is that, look at the y right here. They have the opposite sides, okay? If you decide to use the first and second equation, look at that. Your goal is to eliminate the y, but the first two equations have the side of the y, okay, are the same. You want the opposite side. Opposite side you can eliminate. If it's the same side, you cannot. Okay, that's why I'm going to use the first equation and the third equation, because the sign of the variable y are opposites, plus and subtracts. it fit my purpose. I want to eliminate y. I want the y to be 0, okay? I mean, I want the coefficient of y to be 0. So, let's see. Let make space. I'm running out of space. So, I'm going to copy only this result, okay, here. Solution. So what we got so far is negative 2x plus z equal to 0. And I call this equation 4, okay? Because we have D3 ready, but let's call the next one 4. So I'm going to erase this. And I'll focus on the first and the second equation now. Sorry, the first and the third equation now. So 4x subtracts 2y minus 3z equal to 5, equation 1. Equation 3 is 2x plus y plus 2z equal to 5. And this is equation 3. Let me move this here. Let's verify one more time. 4x subtract 2y, subtract 3z equal 5. 2x plus y plus 2z equal 5. Alright. Remember, the goal is to eliminate y. Okay? So, to eliminate a y, you need to have the same coefficient with opposite side. Opposite side, we got already, so which is good. But the coefficient for this y right here is 2. I mean negative 2. Coefficient for this y right here is positive 1. So you need to have the same coefficient, which is 2. Okay, the length of the coefficient. So I'm going to multiply 2 on both sides. Okay, because if I multiply 2 here to the y, I get positive 2y. Okay, positive 2y, subtract 2y 0. It fit my goal. So again, let me do this so I know that these are the system of two equations I'm working on right now. Okay, so this first row right here, I haven't changed anything, so I just copy it in exactly the first equation. Alright, so for this equation right here, equation 3, we decide to multiply 2 on both sides. Let's simplify. 4x, 2 times 2x is 4x, 2 times y is 2y, 2 times 2z is positive 4z, 2 times 5 is 10. Okay, now, if fit out, we can start eliminate the y now, right? So let's add them. When it's ready, you can add them. 4x plus 4x is ax. Negative 2y plus 2y is 0. 4z subtracts 3z, or negative 3z plus 4z is just z. 5 plus 10 is 15. Simplify, we get ax plus z equal to 15. Alright, so this is the second equation we just obtained. So let's copy it here. Ax plus z equal to 15. And let's call this equation 5. Okay, so far we have 5 equations. Look at that. Look at the equation 4 and 5. This is a system of two equations with variable x and z, right? So if you have an equation with two variables, and if you can find another equation with the same variable, guaranteed, you can solve for those two variables, x and z. Okay, so I'm going to make space, so I'll take this out. And you already learned how to solve a system of two equations, okay? So this is just review. So we have negative 2x plus z equal to 0. This is equation 4. And we have ax plus z equal to 15. And this is equation 5. Okay, let's check the work. Ax plus z equal 15. Now, we need to solve for x and z. If we can find x and z, we can solve for x. Okay. To solve for this, look like you can eliminate the z, right? We're using the elimination methods. Okay, elimination method. So look like we can multiply. Actually, look like we can eliminate the variable x right here. We can eliminate this by, or z. It's really up to you. So you picked either z or x. Your choice can make the problem easier or harder. I think I probably would eliminate a z. So to eliminate a z, I need to have opposite sign. Okay, the length of the coefficient is the same. Okay, 1, 1. The only thing I need is dz must have opposite sign. So let's say I multiply. Okay, I call this a system of two equation. So let's say I want to multiply -1 here. Okay, on both sides. Okay. If I multiply -1 on both sides, look at that. -1 times this z right here is -z. So that means I can eliminate with this z. Alright, let's simplify. So this is first system, second system right here. -1 times -2x is positive 2x. -1 times z is -z. 0 times -1 is 0. Copy this equation 5. Alright, look like you're ready to eliminate the variable z. So let me add d2. Okay, 2x plus ax is 10x. Plus z subtract z, or subtract z plus z is 0. 0 plus 15 is 15. Simplify 10x equal 15. To solve for x, divide both sides by 10. X equal to 15 divided by 10. Now, you're not done yet. This is not a simplified answer because this is multiple of 5, right? And this is multiple of 5. Look like you can simplify to further. So if you divide 5, okay, you divide, take 15 divided by 5, 10 divided by 5, you should get 3 over 2. 15 divided by 5 is 3, 10 divided by 5 is 2. So x is 3/2. Okay, so we have x 3/2 here. Okay, let me copy what we got right here to make space. So x is 3/2. We need to solve for y and z. Okay. To solve for y, z, let's see. So far we know x. So look at all the equations 1, 2, 3, 4, 5. These two equations form 5. It has the z, right? So actually you can use this equation to solve for z. You cannot use the first three equations. You cannot, okay? You cannot use the first three equations because so far you only know x, okay? You only know x. You don't know y and z, okay? If there are 3 variables, to solve for one variable, you need to know the other 2 variables first. Okay, given 3 variables, x, y, z, to solve one variable in the 3, you need to know 2 out of 3, okay, of that equation. If you only know 1 out of 3, you cannot solve it. Like this equation right here, 4 and 5, since there are only 2 variables, you know 1, that means 1 out of 2. That means you can solve for it. So let's see, we can pick 4 or 5. Which one you want to pick? I probably pick this equation, the first one. Just the number look easier. This is 0, this is 15. This is a, this is -2. So I'll pick equation 4. -2x plus z equal to 0. This is equation 4, okay? And I substitute x and 3/2 into here to solve for z. So -2 times x is 3/2 plus z equal to 0. Simplify. -2 in the numerator, divide by 2 in the denominator, become -1 times 3 plus z equal to 0. -1 times 3 is -3 plus z equal to 0. To solve for z, we're adding 3 on both sides. -3 plus 3 is 0 plus z. 0 plus 3 is 3. Simplify, we get z equal to 3. Okay? So this is the second variable we just obtained, which is 3 here. So the last one we need to find is y, the variable y. So let me copy here, z equal to 3. Okay. I'm going to make space. Alright, to solve for x. In fact, you don't have to use the first three equations. Look at the equation 4 and 5. Actually, I'm wrong. Take it back. You need to solve for y. You need to solve for y, alright? Equation 4 and 5 do not have y, so you cannot use equation 4 and 5 to solve for y. So ignore equation 4 and 5. Look for equation 1, 2, 3. It has y there, right? And remember that you know two variables. That means you can find the remaining one, right? So let's see which one is the easiest. Don't pick the hard one. Pick the easy equation to solve for y. It sounds to look like either 2 or 3 to me. I would pick equation 3 because it's positive y here, okay? Positive y. So I'm picking equation 3. So 2x plus y plus 2z equal to 5. This is equation 3. 2x plus y plus 2z equal 5. We'll substitute x equal 3/2 here. And y, I don't know, put it y there. I'm going to substitute for z, which is 3. Okay, equal to 5. Simplify. 2 in the numerator, divide by 2 in the denominator is 1. 1 times 3 plus y. 2 times 3 is 6, equal to 5. Okay, simplify. 1 times 3 is 3 plus y plus 6 equal 5. Combine like terms. 3 plus 6 is 9 plus y equal to 5. Solve for y, subtract 9 on both sides. 9 subtract 9 is 0 plus y equal to 5. Subtract 9 is -4. Simplify. 0 plus y is y equal to -4. Okay, so y is -4. And this order triples. The first coordinate is x, second coordinate is y, third coordinate is z. So if you put these values x, y, z in the wrong odd order, you won't get a correct answer, okay? You will lose point if you put these values in the wrong order. Remember, the first one is for x, second one is for y, third one is for z, okay? First coordinate is x, second coordinate is y, third coordinate is z. So this is how you solve for this system of equation.